welcome to the, I think it's number 3 in our webinar series for data interpretation. As I mentioned briefly there, my name is Marc Pinkerton. I am an account manager here at Fluid Life. I work closest with mining and construction clients, so focus on mobile equipment. You have my email there. Feel free to contact me at any time if you have any questions or comments or follow-up discussion points about this webinar or anything regarding our services. As I mentioned, this is number 3 in our webinar series. So, you know, keep an eye on our schedule for additional webinars on data interpretation. And also past webinars. I think there's one on natural gas engines and on compressors as well. All of these are recorded and available to stream anytime on our website. Additional to myself, you can send generic inquiries or whatever the case is to our customer care department. They're kind of our catch-all for customer inquiries, whether they be administrative or technical as well. Okay, so to get started, today's focus is going to be data interpretation for diesel engines. If any of you are well-versed in data interpretation for diesel engines, the majority of our talking points today are going to be just a refresher. These are going to be pretty basic concepts, pretty basic interpretation examples and stuff like that. But as I mentioned, you know, feel free to contact me later if you want to talk more about specific examples or specific applications or whatever the case is. Okay, so for diesel engines, I'm sure you all know, you know, diesel engines are alive and well in a bunch of different types of equipment. And depending on the application, you know, whether it be mining, construction, power generation, or even what type of equipment that diesel engine is being utilized. So an excavator is obviously different from a dozer, a haul truck, generator, etc. The first thing you should always keep in mind and make this kind of a rule for yourself, know the entire story. So when I say know the entire story, I don't mean just the data. I mean the sample information, you know, so component hours, again, what unit this is from, oil hours, oil type in use, etc. All that stuff is extremely important when reviewing a report. Also remember, you know, what type of environment you're working in. An underground mine is going to be different from, you know, an excavator in civil construction or civil engineering. You know, a dozer with high load or a haul truck that's empty or full or a stationary generator, they're all going to have different loads and different working applications as well. All that needs to be considered in your interpretation. And then finally, you know, also be aware of any maintenance history related to that diesel engine. And, you know, keep a good eye on your upcoming maintenance schedules too. If you encounter something that's not too critical, but you still feel needs some type of intervention, you know, take a look at your schedule. And if there's a PM coming up or, you know, that particular engine already has a repair scheduled, you know, you're not going to have to double up corrective actions. So again, just know the entire story. From the sample information to the application to the working environment to the maintenance histories and schedules as well. Okay, so what are standard tests and what are additional tests? Standard tests according to Fluid Life include viscosity, viscosity index, ICP spectrometry, so elemental concentrations of contaminants, wear metals, and additives, water, glycol percentage, fuel percentage, soot percentage, and ox, NOx, and SOx, so oxidation, nitration, sulfation. These are the standard tests that we recommend to any customer who's doing routine diesel engine oil analysis. We do have additional tests, many more that are listed or that are not listed, But just quickly, you know, things like base number, acid number, those would be useful if you're looking to do drain extension projects, or if you want to change your maintenance strategy to completely condition-based. You know, total magnetic iron and ferrographies, those would be for large particle morphology studying, as opposed to, you know, just ICP spectrometry. So if you think, you know, you have some significant wear occurring and you want to learn more about that wear, those would be the tests that you either do on an ad hoc basis, or, you know, you can add triggers and stuff like that. But today I'm going to be focusing on the standard tests. Again, you can follow up with me or anyone at Fluid Life about the advanced or additional test options. But in general, whatever your goals are related to your diesel engine oil analysis results, your testing scope should reflect those goals. So to jump right in, we're going to start with glycol. So glycol is obviously a contaminant to diesel engines. You know, its origin is going to be a cooling system leak. You know, where exactly that comes from, you know, there's a bunch of abilities. Your main goal with oil analysis should be to use the results to refine whatever it is you're going to troubleshoot, right? So obviously, if you have glycol, the report is not going to tell you exactly where that's coming from, but your knowledge, you know, your maintenance knowledge, Fluid Life can even provide you with troubleshooting guides or your OEM recommendations as well. You know, that should be the main goal. You see glycol, or you see fuel, or you see anything for that matter, how can I best troubleshoot that? So how are you going to identify glycol on a report? You know, obviously, you should see flagged glycol concentration, so glycol percentage. You know, if it's coolant, which it's going to be, it's also mixed with water, so you should have some indication of water as well. If the event is significant enough, the contamination is significant enough, and it's been in there for a while, you should see some increased viscosity as well. And you may see some premature lubricant degradation with, you know, flag, nitration, oxidation results as well. One special case related to glycol contamination in engine oils is the presence of sodium and potassium. It is possible that you have coolant contamination in your engine oil, but due to the engine temperature, that the glycol molecules will flash off. The basic test that we run is gas chromatography, and the test is designed specifically to measure glycol molecules or detect glycol molecules. When they flash off, the byproducts of glycol are not measured by the gas chromatography. We have another specialized test for that, should you choose to add it. But it is possible that you'll see a situation like you see on the bottom here, where you have high sodium, high potassium, but you don't see any evidence of water or glycol. Sodium at these levels, 500, 600, are more likely to be glycol contamination events than they would be to be external ingression of contaminants. I mean, that's possible. But I would say it's more likely just to be confirmation that you still have a coolant contamination issue. So just take a look at both situations there. Both are reflective of coolant ingression into engine oil. Okay, so just one big thing to keep in mind, one big exception about sodium and potassium. Typically on any other oil analysis report, they would just be a contaminant, like a external contaminant. But for diesel engines, obviously, it's more likely, especially at these concentrations, to just be evidence of coolant. Okay, next we have diesel fuel, which is also another big potential issue for diesel engines. Sources of diesel fuel, you know, many reasons why you can have diesel fuel dilute your engine oil. excessive idling. So again, know the application of your equipment, blow-by, damaged rings, faulty injectors, and there's a whole bunch of options. So again, you identify fuel, it start to refine your troubleshooting. Hey, how is fuel identified on your reports? Well, you're going to have a fuel percentage, okay, and resulting or other results that would help confirm the presence of fuel. The next one would be a decreased viscosity. So if any of you have ever worked with oil-based paint, after you're done painting your walls or whatever you're painting, you kind of clean out your brushes and your rollers with mineral spirits or Varsol or whatever the name is, and it thins it out. Essentially, fuel acts the same way with viscosity, right? So 21% is a catastrophic fuel percentage, so you can see your viscosity has dropped significantly, and we can guess what the resulting damage to the engine could possibly be in situations like this. Another indicator, and more so for significant or high concentrations of fuel percentages, you'll also see a slight dilution of your critical oil, right? So all of these things here you would see on a report with significant fuel dilution. Okay, another issue you'll run into is dirt and dust. So external ingression of contaminants into your engine. So, long term, this would be like a dusted engine. The biggest indicator is going to be silicone. Okay, but also keep an eye on your aluminum concentration. This is another exception. If you have a ratio of 3:1, 4:1, basically that's just going to confirm dirt, and aluminum is not necessarily a wear metal in that case. This example that I'm showing you right now, and I hope I'm on the wrong slide, sorry about that. This example has a perfect ratio, but it's not always going to be that perfect. So again, if it's 3:1 or 4:1 or somewhere similar, basically aluminum is not a wear metal in that case, and you're just confirming that the external contaminant is some dirt. In my experience, when you have high concentrations of silicone, you're going to have some resulting wear. So the reason that I added this is, don't necessarily look at this as 6 separate flags. One of the goals of oil analysis is to boil down all of the flags into one story. So the story here would be, yes, I have dirt entry, dirt and dust entry, which has caused some severe wear of iron, lead, tin, chromium, etc. Okay, so pretty straightforward. Next, we'll move on to water. So the way that we test water is with the crackle method. We do offer Carl Fisher methods if necessary. For diesel engines, it's not too critical because you guys are changing your oils on a frequent basis. Usually when we get a sample, the oil is changed anyways. And water ingression for diesel engines is typically going to be from condensation anyways, and there's not that much that you can do about it. But just a quick little summary on how we would report these. You're either going to get an N, a PR, a PU, or a PS. Anything with a P in front of it means, we've positively detected water via the crackle method. And then we do our best to give you a category or a severity of the level of water that we found. For thicker, darker oils like engine oils, PR is going to start around the 500 parts per million mark, so about 0.05%. A lot of engine oils and engine manufacturers, this is not too bad. The oils can handle it, especially if you're changing on a 5-hour or 500-hour basis. But once you start to get into, PS, so over the 1,000 parts per million mark, that's usually when we start to see some saturation, and that's when things start to get a little bit dangerous. But again, you just have to monitor your trending. If it's a one-off event, maybe not the worst thing in the world. If you see it consistently, then maybe that's something you have to troubleshoot. Okay, the next thing would be soot. So like glycol, like fuel, there are a bunch of reasons why you're going to see elevated soot on your reports. An individual soot particle is extremely small and not that dangerous. However, they are charged particles. So once they start to combine with each other, when they reach a certain size, they become extremely abrasive. So that is the danger there. And also the same charges that force them to combine to each other also promote them to depositing on the surface of your engine components. Okay, so how are we going to detect soot? Obviously, there's going to be a soot percentage on your report. And depending on the severity of the situation and also the age of the oil, so let's say your soot buildup is due to an extended drain interval. So you left a piece of equipment out in the field, double its drain interval, let's say. That's an exaggeration. But you're likely also going to see some evidence of the oil being chemically degraded, so high oxidation, and also a thickening of the viscosity too. So keep that in mind. Yes, I have soot, but do I have any supporting documentation that maybe leads me to think that it's because I left the oil in service too long or the oil is being cooked? So is there chemical degradation as well? If it's standalone soot, then it can be different problems. Maybe then it's the EGR system or something like that. So a good thing to keep in mind, when you have high soot, look for other supporting results and also keep an eye on your oil hours. Okay, oxidation, nitration, sulfation. This is probably the category of results that I receive the most questions about. I tried to boil it down as simple as possible. So oxidation is just the chemical process in which oxygen reacts with the oil. This is heavily influenced by temperature and contamination, especially water. Oxidation happens naturally. It's why we can't leave oils in service forever. Oil manufacturers, a part of their additives is to slow that process or even fight against it. But it always happens. The thing that you want to monitor is how fast the oxidation process is happening. Okay, nitration is the same type of process, except it's when nitrogen reacts with the oil. This is more important for natural gas engines, mostly because of the fuel type. So you're still going to get these on your diesel engine reports. You can utilize them, but I would recommend, focus on oxidation. Sulfation is the process in which sulfur products will react with the oil. This depends on the quality of your fuel or if you have any sulfur additives. It was more of an issue, say, back in the day. Everyone is using the ultra low sulfur diesel now, so it should never be an issue resulting from your fuel. But again, just something to keep an eye on. In general, these three results just kind of indicate the overall level of degradation that has occurred in your engine oil for a bunch of different reasons, but it can be, the oil or the engine and the oil is overheating, so premature degradation, extended service interval, or some significant contamination event that's changing the oil chemistry. Okay, moving on to ICP spectrometry. So we looked a little bit at those elemental concentration results when talking about dirt and dust and glycol. So that covers off the contaminants portion. From a wear metal perspective, it's very difficult to utilize these, you know, so for example, I have 200 parts per million of iron. Okay, that's great. I have some wear, but where exactly is that coming from in my engine? You know, how many engine components are made of steel or of iron? So it really is an art to try and pinpoint where this wear is coming from. So when I'm talking about troubleshooting is make your best guess based on the information that you have. So, you know, iron is kind of a standalone. It's really common, but for things like lead or copper, you know, those are more bronze alloys or softer metals. So, you know, bushings, bearings, stuff like that. Nickel, chrome, sure, rings, liners, exhaust, but also anything that's plated, and aluminum if it's not a contaminant, so a portion of the dirt, you know, that would come from bearings, bushings, cylinders, pistons, etc. as well. In terms of additives, additives have, well, engine oil additives, engine oils have the highest concentration of additives compared to other oils that you'd be using in your mobile equipment. These are things like detergents, dispersants, antioxidants, etc. You know, detergents would be like calcium, magnesium, antioxidation, anti-wear would be stuff like zinc, phosphorus. It's not necessarily extremely important for you guys to know exactly what each element represents in terms of additive functionality. Basically, what you want to use these for is to try and identify lube mixing or the completely different product being used in your diesel engine if someone topped up incorrectly with a hydraulic oil or something like that. That's kind of the main use. You can also identify additive depletion, but that becomes a little tricky where, you know, some additives when consumed will fall out and be filtered out, while others, even though they're not functional from an additive perspective, will still remain soluble in the oil and will still show up on these reports. So my recommendation, if you're just getting started with data interpretation and are not too familiar with the subject, would be to utilize these results to identify lube mixing or top up with the wrong oil or a change in formulation or whatever the case is. Fluid Life has a bunch of these quick reference charts. I just chose to put this one on. This is something you can request from us at any time. Basically, you know, it's going to give you a little cheat sheet that says, you know, iron, where are my potential iron sources from? You know, same thing goes for copper, you know, calcium. One thing I did not mention is, you know, calcium, depending again on your environment, calcium may not always be an oil additive. If you are operating a loader or something like that at a cement plant, and there is a bunch of dust flying around, chances are calcium in that case is going to be a contaminant. If you work at an iron ore mine, you know, there's going to be dust flying around as well. Maybe in that case, iron is not necessarily a wear metal. It could be a contaminant as well. So again, when looking at these results, always, always, always keep the engine application and working environment in mind. And also feel free to ask us for these little cheat sheets and interpretation guides as well. Okay, viscosity. Viscosity can go up or down. If it there's a bunch of different reasons why that can happen. Again, you could mix with a different project, a different product. Could be due to contamination with glycol. The oil could be left in service for too long, so oxidation is high. Your oil's thickening up from byproduct accumulation. Or it could just be premature degradation as well, so significant overheating. For decreased viscosity, again, it can be contamination, so fuel, right? Lube mixing with a different lower product, so someone tops up with a 32 hydraulic oil, for example, and then improper lube selection, which is kind of like a general reasoning for decreased viscosity. If you pick a 32 hydraulic oil where a gearbox calls for a 680 grade or something like that, obviously it's gonna tear it apart and you'll see viscosity drop. The same thing can happen in engines. It's less likely to occur. Hopefully you guys only have maybe 1 or 2 engine oils on site to choose from. So yeah, just a quick summary. What you should do with viscosity, though, is always look for supporting results. So other flagged results or other results that are off trend or whatever the case is to explain why viscosity has changed, either gone up or down. Okay, so in general, these are the kind of steps you want to take when looking at a report. You know, what are the actual results? What are the flags? What does the lab say in terms of comments, follow-up recommendations? Again, like I mentioned before, confirm your service hours, your component hours, any recent repairs or problems. You know, if you have high wear on a new piece of equipment, well, you can check that off as break-in, you know, and your corrective action there would just be to make sure the oil is changed, monitor future samples to make sure wear continues to go down. Oil service hours, you know, you're not going to look at an oil that has 250 hours on it compared to an oil that has 1,500 hours on it if it's in the same application. And then after that, you know, if you're still not sure, you can reach out to Fluid Life or whoever your lab is, your equipment and manufacturer, your oil supplier. If you have reliability consultants, they should be able to help you out as well. But the goal is to understand the results and then kind of go through this response process here. You know, is this something that I can ignore? Is this something that I can maybe add to my watch list, build trending, and just delay my corrective action or overall decision? Is this something that I have to monitor more closely? So I'm not really sure if this is a big issue yet. Maybe I will sample at mid-interval to see the evolution of this problem. You know, is it something worth performing an inspection? So I found Glycol. I have a Glycol troubleshooting guide from my OEM. I'm going to include that in my next work order or PM. After the inspection, does it merit a repair? Is this something that I really can't, you know, improve? So is this something where maybe I have to look at changing my PM interval, you know, shorten my oil drain cycle to prevent, you know, premature degradation or whatever the case is. Okay, so all things to keep in mind. And now we're going to kind of go into some examples. Okay, so example number 1, and again, this is kind of a beginner perspective, so it's just supposed to be very apparent. Unfortunately, I haven't included full reports, but I've just included, you know, kind of the meat and potatoes, the message that I'm trying to get across here. So I have 2 histories. I have oil at about 900 hours and another oil at about 750. My previous sample at about 900 shows about 9.2-ish% fuel. I have viscosity decrease, but I don't have that much wear. Okay, my most recent sample with less time, I have more fuel, so this issue seems to be getting worse. Viscosity has decreased even further. And now to add a little insult to injury, I also have some silicone contamination. Okay, so maybe some dust entry as well. So the story here should be, okay, my primary indicators is my fuel is getting worse, and now I also have some silicone. Okay, so your train of thought should be my primary indicators here are my contaminants, which has led to a decrease in viscosity and some accumulation of wear here, especially the iron. Okay, so my corrective action here would be, you know, first of all, I want to make sure that the oil has been changed. If it was sent back into the field, that buys us a little bit of time, okay? Because I'm assuming that the oil sample was taken during the oil change, it's back into the field, and now I have the report in hand. For something like 13%, that's pretty significant. So again, I'm not going to make any comments depending on your operations, but I would likely bring this in immediately, and then I would start my troubleshooting process. Where is the fuel coming from? And in terms of silicone, this is, for lack of full history, right now it's an isolated event. So I could take a quick look at my intake system, or, for a lack of time and resources, maybe I want to focus on my fuel sample for now, or my fuel concentration for now. Okay, example number 2. Okay, again, this is a very apparent issue, so I want to identify what my primary indicators of problems are. So here, what do we have? We have some sodium. Okay, I'm going to correlate that with my glycol and water. These 3 results are tied to each other, therefore I can confirm right off the bat that I have a coolant issue, a coolant leak issue. I know my oil is over 1,500 hours, so this might be like a haul truck or something like that. It's not new by any stretch of the imagination. It's not 250, 300 hours. So yeah, it's not surprising. At this concentration, I do have some chemical degradation as well of my oil. So the oil has changed chemically. I have a little bit of thickening of my viscosity as well, and I have some resulting wear, okay, and a little bit of silicone as well. Silicone, in the past 2 examples, it's pretty common, especially, these diesel engines, haul trucks, stuff like that, excavators, dozers. You're always pretty much working in dirty environments. So don't be surprised if you have, it's not going to always be elevated, but you should always expect to have maybe, 10 parts per million or a bit more of silicone. But again, don't focus on that. Focus on the major issue here. This is a clear-cut example of coolant leakage resulting in some engine wear. Okay, so again, depending on when you get this report in your hand, it's very important to make sure the oil was changed. Try to pull this in as soon as possible, and then start some cooling system troubleshooting. Okay, example number 3. So again, I'm looking for some primary indicators. I have high soot concentration, and I have high levels of oxidation, nitration, etc. Okay, so I have some abrasive soot, and I have some potential for premature degradation. But here I'm going to look at my oil hours. Let's assume this is a 500-hour change interval. So what does this tell me? Okay, I have soot, I have evidence of chemical degradation, but my viscosity is still decent. It hasn't gone up as much as we've observed on other reports. Okay, so I'm at my change interval. I have high soot. Yes, this is all flagged, but I'm at the end of my interval. Viscosity has still been okay. So my main focus now is going to be my soot. Why do I have soot accumulation? Okay, it's causing some wear, especially for my softer metals, copper, lead, so my bearings, bushings, stuff like that. So basically, my troubleshooting, my corrective action is going to be focused on why do I have the high soot concentration. Okay, example number 4. So we have here, we have a lot less flags. So again, I'm going to be looking for primary indicators. So no glycol, no fuel, soot seems to be okay. Viscosity is okay. No water. Oil samples have been taken around the same oil drain interval. The oil was changed, yes. Okay, so the only evidence I have here is silicone. So that immediately is going to tell me that I have some external ingression. No aluminum. So this is just going to be straight up dust. Okay, it's not necessary. We didn't confirm that it's dirt here, so it's just going to be general particulate into the engine. I have a lot of wear, so this, without a doubt, should spark you to troubleshoot the engine air intake system. You know, is my filter, was it blown out? Do I have any cracks or anything like that where small little dirt and dust can be getting in? Okay, one comment to make about wear and about silicone concentration or any elemental concentration is there is one big limitation regarding ICP spectrometry results. So any elemental concentrations you have here is that once a particle, a solid particle, surpasses around 5-6 microns in size, our instrument cannot break it down sufficiently enough for it to be measured in elemental concentrations. Okay, so anything that you see in terms of wear or contaminants in the elemental concentrations here are going to be below that particle size limitation. We do not perform isoparticle counts on engine oils because typically soot causes too much of an interference, and our particle counters cannot distinguish between, you know, what is a wear particle, what is a contaminant particle, and what is a soot particle. That's the main reason we don't do it. If you have these type of results on a consistent basis, then it's time to start, you know, considering doing a total magnetic iron, or it's also called a PQ index, or if you want to do an analytical ferrography where we observe your contaminants or your wear metals under a microscope, and we can distinguish, you know, is it wear, is it contamination, what is the type of dominant wear, to give you a little bit more insight as to what's going on. So a little sidebar there about the elemental concentrations, but still very important to keep in mind whenever you're reviewing any type of oil analysis report, not just diesel engines. Okay, moving on. So example 5. So pretty much everything that I've shown you thus far has been clear-cut, obvious examples. You know, fuel is at 21%, glycol is at 2%, sodium is at 500, or soot's at 2, or, you know, whatever the case is. What you are going to come across with routine analysis is that you're going to have a lot of reports like this, where you might just see one single result flagged as yellow. So it's reportable, it's not severe, it's not something that's going to jump off the page and say, I have to go do some fuel contamination troubleshooting or fuel dilution troubleshooting. Okay, a lot of oil analysis is trending, and a lot of it is just monitoring, picking individual components to monitor and keeping a close eye on them before things get too bad, or determining that there are isolated events. So here's an example of that. Okay, my viscosity is good. My oxidation, so my evidence of degradations are good. I don't have too much wear. You know, I have 25 and 42. Okay, as long as I didn't jump from 25 to 100 or 150, I can accept that. What I do have here is I have some flagged water. So again, I'm going to consider my environment. It was extremely humid these past couple days, and you know, I shut my engine off and let it sit for a while. Or this is an underground scoop that was brought up to the surface, you know, so you have some condensation. So this would be more typical of a report that you just keep an eye on. Okay, I see the water. It's not crazy high. Everything else is fine. I've confirmed that the oil has been changed. So maybe I'll keep an eye. Maybe I'll put this one on the watch list and see what the next result brings. You know, I'm not going to run out and ask my technicians to troubleshoot for water ingression or whatever. I'm going to keep an eye on it. I'm going to delay my response and see how the results evolve. Okay, this would be another example of that. I have 2 events of iron wear. Okay, if I look back at my other results, okay, I don't have, clear-cut evidence of any major problem. So soot is okay, no fuel, no glycol. Chemical degradation is okay. My viscosity is a little low, but well within acceptable range. No evidence of dirt or dust ingression. So basically, I just have wear. So this is an example where you should start to mature your routine program by making sure that the flagging limits that your lab produces are in line with what you would consider a real problem. Let's say this is an old engine and you're expecting wear and you're not going to react to this type of problem. You're basically going to run it till it dies unless anything huge jumps out at you. Okay? You can decide, if you go through our data interpretation process again, step 1 was deciding, is this even a problem? Or it might have been step 2. Even if there are flags on here, it could not necessarily be a problem according to your operations and maintenance policies. So that's where you can go one step further, contact your lab and say, I would like to modify my flags, or you can just ignore this result, continue to trend it and live with the flags here. It all depends on how you guys want to manage your program and your program specifications and parameters and all that good stuff. Okay, so again, one last time, just as a quick reminder, want to kind of walk you through the data interpretation process. So after you know the entire story, kind of go through this little checklist here, decide again on the severity what you want to do as a corrective action, if at all, and try, if possible, to document your thoughts for future reference. If you have an operation where you have multiple planners or multiple reliability engineers involved in the data interpretation process and the follow-up process, even if you don't do anything, even if you say we don't agree with our lab's flags, we're not going to take corrective actions, that will still be helpful in the future for future reference, or for a cross shift or someone like that jumping on. So try to document as much as you can and follow this response process as much as possible. Okay, in terms of fluid life, obviously we're an oil analysis lab. You can reach out to us for training as well. So any data interpretation, myLab training, or any certification-based training that you're looking for. In terms of reliability services, so we don't just want to leave you guys holding the bag with reports, especially if you have limited resources in terms of manpower or time or knowledge even. So you can contact us to help you with the data interpretation, troubleshooting, and corrective action process as well. Okay, so that's about it. Like I said, this was just a basic overview of the basic principles of diesel engine data interpretation. Feel free to contact anyone at Fluid Life if you have more questions, and keep an eye out for sure on our data interpretation webinar schedule. I know we have a couple more coming up, and also if you'd like to review any of this information, this presentation will eventually be available for streaming online on our website. So thanks again. I appreciate everyone joining in, and I hope you learned something today.
There is a couple of questions here, Mark. Is there always an EP additive on the diesel engine?
Is there always? Well, there's always going to be a high amount of additives in your engine. Some of those are going to be detergents, anti-wear. There could be some extreme pressure as well. If you really want to find out exactly, I would recommend that you contact your oil distributor. But yeah, you should have some anti-wear, some extreme pressure additives in your diesel engine oil just to prevent some premature wear or some accelerated wear. But again, if you want to know more about the actual additive formulation, contact your lube distributor or the oil manufacturer directly.
Hey, and there's one last one for you here. So basically what the question's asking is, so if you store an engine for a long period of time without it operating, is it necessary to be conducting oil analysis? So basically, if you have an engine that hasn't been running, stored for a while, no operating cycle at all, should we still be testing that oil?
Yeah, well, I mean, it depends. I would recommend definitely testing it before you start up again. If it's been parked for a long time, I'm sure there's some type of SOP to get that piece of equipment back up and running, right? If you can guarantee that this thing was 100% stored and that oil there's nothing being able to touch that oil. So absolutely no moisture, no dirt and dust ingression at all, anything. That oil is sealed off, it's pristine as that equipment's being parked, then sure, you don't need to test it. But that's an ideal thing. I doubt in a real world scenario that's the case. So, an oil sample is not that expensive compared to other maintenance costs related to a critical piece of equipment. So if something's been parked and you guys are planning to get it going again, you don't necessarily need to sample it on every month if it's sitting there for 6 months, but you should definitely sample it to at least get the state of the oil before you start it back up again.
Okay. And another one here that popped up for you. So do we have sample quantity guidelines for like bearings and that? I think we have all that available on our website, are the general recommendations for when to sample various types of components.
Yep. So if you can go back to slide number 5 for me quickly, Drew.
Okay.
All right. So basically, like I said, the testing scope should reflect your goals, and it's also going to reflect the amount of sample volume required for standard tests. So everything that I talked about here are standard 100 ml bottles are more than fine. It's even a little bit overkill. We always like to have additional sample if we need to rerun anything or do additional tests. For the standard tests, and this is pretty much true for any lab you use, I'm not going to speak to other labs' requirements, but in my experience, 100 mils, so our standard bottles, fill that up as best you can, and that should be more than enough.
Perfect. So I think that's about it here. So if there's any more questions from anyone, please feel free to reach out to us. You can email myself, training@fluidlife.com, or then we can go from there. So thank you very much, Mark, for the very in-depth webinar. Lots of good information, and we will see you guys in a couple weeks for the next one.